Alright, so in chapter 2, section 4, we're doing derivatives again, but now there's new tricks that we can use. Um, Chapter 2, section 4 talks about the product rule and the quotient rule. So when looking at your text, they give you the formula to find the derivative of a product of two functions. The way that they describe it, so when you have the product of two functions, to take the derivative of that, you take your first function as is, multiply it by the derivative of the second, and then you add the second function as it is times the derivative of the first function. So with looking at something like number 6, this one doesn't have to be done with a product rule because we could actually distribute this, but it also can be done with the product rule. So if you look at it, again, the cube root of x is just x to the 1/3. So I could say the answer is x to the 1/3 times my second function and then plus the derivative of my second function, which is just 1, times whatever my, oh no. So here's my first function times the derivative of my second function, sorry. And then, so the first function times the derivative of my second, it really doesn't matter the order since it's plus, right? 2 plus 5 is 5 plus 2. But following the book's process, you take the first times the derivative of the second. So here's my first times the derivative of the second plus the derivative of the first. So that would be 1/3 x. And when I subtract 1 from 1/3, I get negative 2/3. And then I have to multiply that by whatever the second function is, in this case x plus 6. Now I want you to notice that that's not what they have, right? They have something that looks a little different. And I'm going to tell you that they are the same, right? If you combine these, you will get this answer. WebAssign should take this as the answer. And I want to verify this. WebAssign's pretty smart. There's a whole bunch of different forms of the answer, but it gave us credit for that. And honestly, that's all I expect you to do, is make sure you use the product rule and use it correctly. Because then if we wanted to find a value, I always could just input this. Input x equals 8 and plug this in. But these two things are equivalent. Another one to talk about is number 3. So we just did the product rule and now there's the quotient rule. So with the quotient rule, go over a couple pages, it's when you have you're dividing two functions, assuming that g of x not equal to 0 because zeros on the denominator are bad. So its process is you take the bottom one, multiply it by the derivative of the top, minus the top one times the derivative of the bottom, all over the bottom one squared. I always tell students, and it's how I was taught, low d high minus high d low over low squared. So that's just referencing which function's on the high side and which one's on the low side. So low d high minus high d low over low squared. And that's kind of easier to remember. Low d high minus high d low over low squared. So if you're looking at this one, you would take low times the derivative of the high minus the high times the derivative of the low all over the bottom thing squared. That would find you your derivative, and then we can plug in x equals -1. One more to look at is something like number 9. And so this one, you're finding the tangent line, right? So eventually you would if you're looking at the point 0, negative 24, right? You're trying to find out what the slope is at 0 when x equals 0, but you'd have to find the derivative of this equation. Now this one is a combination. It has a product and it has a quotient rule in it. So I'll do a supplement on a couple of these problems, but then you're asked to find the equation of the line. So that's just your point slope form, y minus y1, and we have y1, equals the slope evaluated at 0, which we'll be able to find after we take the derivative of this, times x minus x1. So it's really getting to know these formulas and playing with them, the quotient rule and the product rule for section 4.